In our first video on integration by parts, we looked at a couple of fairly straightforward applications of the integration by parts formula. In this video, we'll look at a couple of more sophisticated ways of using this formula. So recall that the formula is u v prime dx equals uv minus u prime v dx. So what we're going to look at is we're going to try to find the integral of e to the x sine x. So let's go ahead and apply integration by parts as we normally would. Let's take u equal to e to the x and v prime equals sine x. So u prime is ex and v is minus cosine x. And let's put all that into the integration by parts formula. So this tells us that the integral of e to the x sine x dx is u times v, e to the x times minus cosine x, minus u prime times v, that's e to the x times minus cosine x dx. So we get minus e to the x cosine x plus e to the x cosine x. So we're back to a very similar kind of integral, and it doesn't look like we're making a whole lot of progress, but we plow on and repeat the process, being careful to again use u equals e to the x, otherwise we're just going to reverse what we just did. So now we go ahead and we calculate e to the x cosine x in the same way. We set u equals e to the x, v prime equals cosine. So u prime is e to the x and v is sine x. So the same kind of procedure gives us that this integral is uv, e to the x sine x, minus u prime v, e to the x sine x dx. So we've got back to the problem that we started with. It looks as if we're going in circles. But if we look at our answer carefully, we see that in fact we can now deduce the solution to this problem. Let's go ahead and substitute this equation back into this one here. What do we get? We get that the integral of e to the x sine x is equal to, well, sorry, this was the formula from the previous page. When we plug in this into this term here, we get this. But the negative e to the x sine x can be taken over to the left-hand side of the equation. We add it to both sides of this equation, and we get 2 integral of e to the x sine x dx equals the right-hand side, what's left of the right-hand side, minus e to the x cosine x plus e to the x sine x. So by dividing by 2 now gives us our answer. That the integral we're looking for is equal to 1/2 e to the x sine x minus cosine x. I just slightly rewrote the right-hand side in a more compact form. So we can think of this as kind of repeat and solve. We repeat integration by parts twice, and then we get to a situation where we're back to the original integral, but we can take it over to the left-hand side of the equation and solve for the original problem. Let's have a look at another example of this process. This is an example of another application of integration by parts, which is to create recursion formulas. A recursion formula is one that gives us the answer to a general problem in terms of a slightly easier one. So for instance, if we have the integral of sine to the nx dx, then a recursion formula would express this in terms of a lower power of sine, because eventually by repeating this operation we'd get down to either sine squared or sine, which is an integral that we can do by other methods, and eventually we would solve the problem. So I'll talk a little bit about how to apply these formulas in a minute. Let's have a look at the problem sine to the power n of x dx. So in order to make this into an integration by parts problem, we have to split it into a product. So we'll take u to be sine to the n minus 1x and v prime equals sine x. Of course, we couldn't take much else for v prime because we don't know how to integrate sine to a large power. So we'll just chip off one piece that we know how to integrate and see what happens. Well, u prime, being careful here, u prime is n minus 1 sine to the power n minus 2x cosine x, and v is, as usual, minus cosine x. So let's apply the formula. So the integral of sine to the n x dx is equal to uv, which is this, minus u prime v, which is all this. I won't say it out loud. So over here, the first term is minus sine to the n minus 1x cosine x. And here we take the minus out, we get plus, and cosine squared x, sine to the n minus 2x with a coefficient of n minus 1. So what are we going to do now? What we're going to do is we have this cosine squared. We're going to change it into 1 minus sine squared. So the top two steps are just the steps from the previous page. So we continue from this point. We replace cosine squared by 1 minus sine squared. And then we split this last integral into two integrals. This is sine to the n minus 2x times 1 minus sine squared x is actually sine to the n minus 2x minus sine to the nx. So we have n minus 1 times the integral of sine to the n minus 2x minus n minus 1 times the integral of sine to the nx. Now again, you see we've reduced the problem. On the right hand side we've got the original integral again, and so we can again take it over to the left hand side, and that will give us 1 times this integral plus n minus 1 times that integral. So that'll give us n times the integral of sine to the nx dx, and it's equal to this first term again, plus n minus 1 the integral of sine to the n minus 2x dx. So this is where we can stop. This is what after we've divided by n, we get what we call the recursion formula for sine to the nx. It expresses the integral of sine to the nx dx in terms of an expression plus an integral of a smaller power. And given any specific value of n, by applying this recursion formula repeatedly, we can eventually get the answer to our problem. Let's have a look at a quick example of that. Let's take the case n equals 5. So we write out this formula for n equals 5. It's minus a fifth sine to the 4th x cosine x plus 4/5 the integral of sine cubed x dx. So now, then we need to calculate this. So again, we apply the formula with n equals 3. And that gives us minus a third sine squared x cosine x plus 2/3 sine 3 minus 2. That's just sine to the power 1, or sine x. And then we can integrate this and get cosine x. So, keeping in these constants here, 1 over n is a third, n minus 1 over n here is 2/3. So we get this expression for sine cubed, and now we can substitute that back up there and get a complete answer to sine to the 5th. And I will just leave it at that. I won't read it out for you. So this is definitely a more sophisticated technique than we've seen in the earlier video. It's not such a common one. Certainly the first example applies primarily to that example e to the x cosine x and similar kind of integrals. And this technique also works for sine to the nx and cosine to the nx, but it's not particularly applicable beyond that. But these are important techniques to know.